Working with relationships in semantic models reveals several complex mysteries to solve. How do you set up relationships between different tables of data? And how do they affect the way you filter and analyze your data? We'll unlock these questions and more. You'll discover how to apply star schema design principles, how to choose the right cardinality and cross-filter direction, how to activate or deactivate relationships with DAX functions, and how to understand relationship evaluation and precedence rules. Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Gather your evidence bags and let's start investigating, starting with our first case, the model mystery. A model relationship propagates filters applied on the column of one model table to a different model table. Filters will propagate so long as there's a relationship path to follow, which can involve propagation to multiple tables. Relationship paths are deterministic, meaning that filters are always propagated in the same way and without random variation. Relationships can, however, be disabled or have filter context modified by model calculations that use functions. Model relationships don't enforce data integrity. Here's how relationships propagate filters. In this example, the model consists of four tables: category, product, year, and sales. All relationships to the table are one-to-many, which we'll cover in a bit. A query asks for the total quantity of sales orders in a category, category A, and a year, calendar year 2018. Filters on the category and year tables reduce the product table to two products in category A and the sales table to two sales rows for these products. Their total quantity is 14 units. The year table filter also reduces the sales table to one sales row in category A and calendar year 2018. The query returns a quantity of 11 units. Multiple filters on the table are always an AND operation, meaning all conditions must be true. Now that we have a better understanding of what model relationships are, our next case to crack is the star schema. We recommend you apply star schema design principles to produce a model comprising dimension and fact tables. It's common to set up Power BI to enforce rules that filter dimension tables, allowing model relationships to efficiently propagate those filters to fact tables. The following image is the model diagram of a data model. It shows a star schema design comprising a single fact table named sales. The other four tables are dimension tables that support the analysis of sales measures by date, state, region, and product. Notice the model relationships connecting all tables. These relationships propagate filters directly or indirectly to the sales table. It's unusual that a model table isn't related to another model table. Such a table in a valid model design is described as a disconnected table. A disconnected table isn't intended to propagate filters to other model tables. Instead, it accepts user input, maybe with a slicer visual, that allows model calculation to use input values in a meaningful way. One example of a feature that creates a disconnected table in Power BI is a what-if parameter. Another special circumstance is attempting to relate a column to a different column in the same table. This is referred to as a self-referencing table and uses this concept to store parent-child relationships to generate a model a hierarchy. This isn't possible in model formatting in this service. There are other ways to generate parent-child relationships, and we'll look at that in a bit. All right, definitions and design recommendation mysteries are covered. Now, how are relationships created? And how does filtering work? Let's crack the case of the cardinal sin. In most cases, a model relationship relates one column in a table to one column in a different table. Each model relationship is defined by a cardinality type. There are four cardinality type options representing the data characteristics of the from and to related columns. The one side means the column contains unique values. The many side means the column can contain duplicate values. When you create a relationship, The service automatically detects and sets the cardinality type by querying the model to know which columns contain unique values. Sometimes, however, the service can get it wrong. You can get it wrong when tables are yet to be loaded with data, or because columns that you expect to contain duplicate values currently contain unique values. In either case, you can update the cardinality type if any one-side columns contain unique values, or the table is yet to be loaded with rows of data. Let's briefly discuss each cardinality type. The one-to-many and many-to-one cardinality options are the same, and they're also the most commonly used cardinality type. A one-to-one relationship means both columns contain unique values. This cardinality type isn't common, and it likely represents a suboptimal model design because of the storage of redundant data. It's often a better idea to use Power Query to consolidate the tables into one. A many-to-many relationship means both columns can contain duplicate values. This cardinality type is also infrequently used. It's typically useful when designing complex model requirements. You can use it to relate many-to-many facts or to relate higher grain facts. For example, when sales target facts are stored at product category level and the product dimension table is stored at product level. You can interpret a relationship's cardinality type by looking at the indicator, which could be a 1 or an asterisk, on either side of the relationship line. To determine which columns are related, you'll need to select or hover the cursor over the relationship line to highlight the related columns. Each model relationship is defined with a cross-filter direction. Your setting determines the directions that filters will propagate. The possible cross-filter options are dependent on the cardinality type. Single cross-filter direction means single direction, and both means both directions, kind of like roads. A relationship that filters in both directions is commonly described as bidirectional. When the cross-filter direction is set to both, an additional property becomes available. It can apply bidirectional filtering when Power BI enforces row-level security rules. You can modify the relationship cross-filter direction, including the disabling of the filter propagation, by using a model calculation. It's achieved by using the cross-filter function, which is described shortly. Keep in mind that bidirectional relationships can impact negatively on performance, so it's recommended to use bidirectional filtering only as needed. In Model View, you can interpret a relationship's cross-filter direction by noticing the arrowheads along the relationship line. A single arrowhead represents a single direction filter in the direction of the arrowhead. A double arrowhead represents a bidirectional relationship. Cardinality essentially affects the flow of traffic of data while filtering out what's being requested. As you can probably deduce, this is an essential concept because ultimately a query or a report visual heavily relies on accurate filtered information. Now, what about multiple relationships between tables? Let's investigate. There can only be one active filter propagation path between two model tables. However, it's possible to introduce additional relationship paths, though you must set these relationships as inactive. Inactive relationships can only be made active during the evaluation of a model calculation. It's achieved by using the useRelationship function, which again we'll look at shortly. Generally, we recommend defining active relationships whenever possible. They widen the scope and potential of how report authors can use your model. Using only active relationships means that role-playing dimension tables should be duplicated in your model. In specific circumstances, however, you can define one or more inactive relationship for a role-playing dimension table. You can consider that design when there's no requirement for report visuals to simultaneously filter by different roles, or you use the useRelationship function to activate a specific relationship for relevant model calculations. In Model View, you can interpret a relationship's active versus inactive status. An active relationship is represented by a solid line. An inactive relationship is represented as a dashed line. Now let's take a look at a special case. We want to speed up queries to direct query tables that have relationships built between them. Any built-in features that can help? Glad you asked. The assume referential integrity property is available only for one-to-many and one-to-one relationships between two direct query storage mode tables that belong to the same source group. You can only enable this property when the many-side column doesn't contain nulls. When enabled, native queries sent to the data source will join the two tables together by using an inner join rather than an outer join. Generally, enabling this property improves query performance, though it does depend on the specifics of the data source. Many of the settings and strategies we covered up to this point can be accomplished through the visual interface. But just like most platforms, you have the flexibility of using programming language to perform these types of operations. This is where data analysis expressions, or DAX, comes in. Now, I've been holding off on saying DAX because my pet, best pal Dax, is kind of a diva, and although hates to be on camera, loves to be mentioned. Yes, Dax, this is where we talk about DAX. Now, go lay down and be good. Let's investigate some DAX functions that can help us work with relationships. There are several DAX functions that are relevant to model relationships. These are listed here along with how they're formatted. The related function retrieves the value from the one side of a relationship. It's useful when involving calculations from different tables that are evaluated in row context. The related table function retrieves a table of rows from the many side of a relationship. The useRelationship function forces the use of a specific inactive model relationship. It's useful when your model includes a role-playing dimension table and you choose to create inactive relationships from this table. The cross-filter function either modifies the relationship cross-filter direction to one or both, or it disables filter propagation to none. It's useful when you need to change or ignore model relationships during the evaluation of a specific calculation. The combine values function joins two or more text strings into one text string. The purpose of this function is to support multi-column relationships in direct query models when tables belong to the same source group. The treat as function applies the result of a table expression as filters to columns from an unrelated table. It's helpful in advanced scenarios when you want to create a virtual relationship during the evaluation of a specific calculation. The parent and child functions are a family of related functions that you can use to generate calculated columns to naturalize a parent-child hierarchy. You can then use these columns to create a fixed level hierarchy. Up to this point, we've covered many ways to help develop proper semantic model relationships. But it's also important to understand how the engine works with these relationships so that we can discover ways to further optimize our model. Let's uncover the clues to solve the case of the performance problem. Model relationships from an evaluation perspective are classified as either regular or limited. It's not a configurable relationship property. It's inferred from the cardinality type and the data source of the two related tables. It's important to understand the evaluation type because there may be performance implications or consequences should data integrity be compromised. A model relationship is regular when the query engine can determine the one side of a relationship. It has confirmation that the one side column contains unique values. A model relationship is limited when there's no guaranteed one side. A limited relationship can happen for a couple reasons. The relationship uses a many-to-many cardinality type, even if one or both columns contain unique values, or the relationship is a cross-source group, which can only ever be the case for composite models. It's not always possible to determine whether a model relationship is regular or limited. A many-to-many relationship will always be limited, as will be a one-to-many relationship when it's cross-source group relationship. To determine whether it's a cross-source group relationship, you'll need to inspect the table storage modes and data sources to arrive at the correct determination. You can tell in a model view if a relationship is limited by the following identifier. We discussed bidirectional relationships and the consequences involved. This could also mean slower performance. Why? The service uses precedence rules for ambiguity detection and path resolution. Those are listed here. If you notice, bidirectional relationships are last on the list, meaning that those types of relationships are resolved last. Last, but certainly not least, the following list orders filter propagation performance from fastest to slowest performance. Now that you have a better relationship with relationships, let's put that knowledge to practice. We'll fire up the DetectoLab 5000 and put this knowledge to work. All right, back in the environment, and now it's time to build our relationship with the relationships. So that's what we're going to focus on in this. So the first thing that we're going to need to do is we're going to create a new semantic model. Now I can use, I've already kind of built the relationships between the default, but if you remember from previous demos, and the default semantic model has some limitations to it. It's great for quick analysis, quick reporting within the Fabric environment, but in order to get more features and options, we need to create our own model, which is kind of what I did here. And we can do that from the lakehouse itself. And I can create a new semantic model from the lakehouse. What I want to show you is the difference between a lakehouse and a warehouse. So my worldwide importer's warehouse, right? I do have a default semantic model. You can see that I'm in the model view. But even when I go into the data view, I don't have the ability to create a new semantic model of the warehouse. So I can only use the default model. So this is great for quick analysis. Now, don't think that you can't, now you might be thinking, well, now I can't use this or do anything else. Well, you still can. If I go into if I have a report open in Power BI Desktop and I just want to connect to the data, I can do that. I can connect to my warehouse. So if I go to Fabric, you can see that I have the warehouse option, and then connect into my warehouse. And then what happens is essentially the tables that are associated with that warehouse become available in this report. And I can utilize that and combine it with other data sources to essentially create a new semantic model if I need to. So that's the workaround for that. But we're gonna work with this lakehouse one since it's easier to do from here. So let's go back in the lakehouse. By the way, if I switch to the SQL Analytics endpoint, same thing. I don't have the ability to create a new semantic model from here. So we got to do it from the Lakehouse Explorer. We'll create a new semantic model, and we'll call this, I think I already have test model. So we'll call this test model 1. And then it gives me the option to select which tables that we've created in our Lakehouse to generate this new semantic model from. So we put a lot of tables in here. Some of these aren't going to apply to this. So we got dimension customer, dimension city, the stock item, the employee, and the date. We made these aggregated tables ourselves. They're just for analytics purposes, like quick analysis, so I don't really need them. The only other one I'm going to need is obviously my fact table, right? So we'll confirm this, and it should create the model for me and hopefully open this up in a new window for me to work with. So we'll wait for this to happen. All right. So it says here, changes will be permanent and automatically saved. That's great. All right, so that's good. Now, I want a little bit more real estate. I know what's here. We're working with relationships, right? So let's expand this out. So I can zoom in, zoom out, do all these things, reposition these. But what we're going to do is we're going to create a star scheme out of this, where the dimension tables filter into the fact tables. Now, there's a few ways that I can build relationships. I'm going to move these kind of in a star schema or a star format so that I can show you the different, you know, what visually this looks like when we get it done. And we'll zoom back out to full mode and maybe move this around just a little bit more, make this look a little bit more starry. All right. So there's a few ways that we can do this, that we can create relationships between models. I can do a drag and drop. So if I know exactly what columns I need to build a relationship between, I can do that. And just as a nuance, if I do it from the fact table to this side, it depends on what we're trying to join it to. It doesn't make any assumptions about if it's a one-to-many or a many-to-many. I'm defining that myself. So I can see that I got a customer key. So I got a city key. Let's do this. So I'm going to drag the dimension city into this fact table, and it should open up my relationships, right? So I'm going to make this relationship active, city key to that. The problem is that it's given me a many-to-one, and I've dragged the dimension into the fact. Now, if I said okay on this, right, and I'm going to assume a referential integrity on all these because these are live connections, so I'm pulling this from source. Now you can see that the many side was put on the dimension and the fact was put on the one side. That's not what we want, right? These should have all the unique values in here, and these should have the duplicates in there. So we'll go back into the properties and we'll switch this to one-to-many. And we'll hit OK, and that should make that proper, all right? So let's do this the other way, right? So I got customer key, and I got customer key here. So I'm going to move it from the fact table to the dimension table. And then we'll assume referential integrity, and then it's a many-to-one. And this one should be okay, right? One-to-many. That's what we're looking at. So the way that this works, when we try to do it that way, that's how we can obviously create that many-to-one as drag and drop. Now, some of these we might not know exactly what key to utilize with this. Like I have an employee key here, and I have a salesperson key, but this isn't that obvious to me. And this is how I'm going to build this relationship. I can also go into manage relationships, and it shows me the relationships that I have. I can create a new one. So if I want to do from my fact sale and my salesperson key to, and I just highlight that, to my dimension employee and my employee key, and I say many-to-one on that, assume referential integrity, we hit OK. That should go ahead and you can see that the many side is on the fact sale. So that's exactly what I wanted. And I can do this for the other ones. I haven't done date yet. Oops, I wanted to show something particular with that. I think this one has a stock item key, right? And then we have, oops, I should have done this from the fact, well, that doesn't matter. I can make it a one-to-many in this case. And then I should have the same stock item key here. Boom, did it. All right. And you can see that the cross filter direction, single to both, I can apply that on these as well from this management, right? Now, the last thing I want to show you is inactive relationships while we're building our model. We're doing a good job. The last thing we need to deal with is our date table. There's going to be cases where your tables are going to need multiple relationships with the fact table, or maybe other tables. But a lot of the times it's with the fact table. I'll just give you an example. Is that you could see here that we have, and I know this is really hard to see probably. We'll just zoom in on this. So from my fact table, you can see that I have a delivery date key and I have an invoice date key. I might actually want to build multiple relationships between this. Why? Because I might want to compare when somebody ordered something as compared to when it was delivered. This way I can find differences or discrepancies on when somebody ordered something and when it was delivered. This could be for optimizing manufacturing processes. Now, my date is usually because that's a whole date stamp or date time object. And that's what I will usually want to associate with this. In the table itself, if I went back into the table, you'd see that this is like a timestamp information as well as these delivery date and invoice date keys. So they should match up. But I'm going to need two of these. So I'm going to create one, and I'm going to make this invoice date key my default or my active relationship, right? So it's active. I'm going to assume referential integrity. We're doing this to the fact table, and I think it needs to be a one-to-many in this case. And we'll hit OK in this one, and that'll create that relationship there. But I also want a relationship between that and the invoice so I can make a comparison on those, right? And it's kind of giving me a weird thing happening, but I think I can still switch this. Actually, let me cancel that. That looks a little funky. Maybe I need to do this from the, we'll try doing it one more time. Date to delivery date. All right, that looks good. So boom, boom. We need to switch that to one-to-many. The thing is that it's not going to let me make that relationship active, right? Because it already has that in there. So I need to go ahead and make that inactive. I'm still going to assume referential integrity on it, and we'll go ahead and put that in there. What I want to show, let me zoom out full again and pull this out a little bit, is how these are labeled differently. Let's zoom back in. So you can see that inactive relationships are identified by this dotted line as compared to a full line. So that's how we identify inactive relationships. So now we have our model, right? And we'll show you how, visuals are, how these apply to certain visuals and things like that. What I want to do is move over to some other, actually some reports that a colleague of mine created that really highlight the use cases for these, for the relationships on here. First, I want to talk about bidirectional relationships in particular. We talked about it in the content, but I want to show you what a use case is for it. By the way, thank you, Wesley DeBolster. He's the one that, he's another Microsoft technical trainer who developed these reports, and very smart, very intuitive about Power BI, and created these reports. So thank you for having this material here. So these bidirectional relationships, I think it's important to point this out. Now, if you can see here that our table, right, our table will contain a customer and a product and a sales. And the way it's built right now is that there's a one-to-many relationship between products and sales. So anytime this is going to filter into this, when I pick and this is a good use case, by the way, for bidirectional relationships. So when I have a country selected, let's say I want to parse through countries. What's happening is that because I don't have this bidirectional relationship associated with it, it's gonna, this product part, since I'm only filtering into the sales, I'm not filtering back into products. So it's gonna give me all the product options in here to select from a slicer. So if I'm in Australia and I pick hats, it's blank. There's nothing there, but the slicer still shows me it's available. And then if I pick jeans, blank. T-shirts, there's 30 of them. If I go to the United States, there's 10 T-shirts, there's 20 jeans, but there's no hats. Now, from a user perspective, that can be a little frustrating, right? Because it's not easy to use. I'm just getting blank values in here, and I don't want my user to experience blank values in my reports. So what we're going to do is we're going to go into the model view, and we're going to take this product, and I'm going to highlight the relationship here, and then I'm going to change this cross filter direction to both, and I'm going to apply the changes here. And this will create that bidirectional relationship. Happened really quick, by the way. But now when I go back into the report, side, and I click on Australia, you see what happened there? It removed it removed all the values, or it filtered all the values out that have blank values in here. This is where bidirectional filters kind of play a good role, as if we have multiple slicers in here. The problem is the potential for ambiguity. I referred to, these relationships as roadways, right? So we got one-way traffic rolling this way, one to many. So traffic stops. First of all, the traffic can't go back in here. So I know that this table's protected from anything else filtering into it, at least from this direction. And this way now, the sales, since I've opened up the roadway, now we got a two-way path. What can happen is if I built another relationship between products, and what I see a lot is that we'll have a sales side. Usually there's a customer side and a vendor side. And models try to get created where we're trying to simplify the process of making a report for both possibilities in here, for vendor side and sales side. Well, if I have products and then it's associated to a sales table, maybe on the vendor side, or vendor items or stock items or something like that, what can happen is that now that I have this filter open this way, if I build a relationship to another table going this way with a one-to-many, I'm actually opening up now this sales filter into that other table. And this is where ambiguity can happen. So typically, if you're going to build a bidirectional filter, make sure that the table is a standalone table, or that you understand the consequences of building this relationship. Okay, that's all I want to point out there. Other thing I want to show is these DAX samples here, because again, Wesley DeBolster did a great job of just got to connect to my VM. Maybe it'll connect. There we go. All right. My Bastion isn't that great. I got a free Bastion, so it doesn't work that great. All right. So related, we talked about some of these DAX functions. Yeah, DAX, I know. I'm calling your name. It's all right. Go lay down. So we got related, right? So what related does is it actually retrieves the value from a one-sided relationship. Where does this come in useful? Well, let's say I want to see sales that don't apply to non-USA, right? Everything but US sales. I might have a different report for that. What I can do then, and this is reflected here, right? In fact, I might be able to pull this in, and if I select the visual, there we go. You can see that I got country, sales amount, and sales non-USA. Apparently there's a measure created somewhere in the sales table maybe that shows sales non-USA, right? And that's what this is right here. So it's a sales territory column to now where I can add that measure in to just get the sales of everything that isn't United States. So I'm just pulling in all the row related information not related with the United States. Awesome, right? Let's look at use relationship. By the way, if you've taken the Power BI course or understand DAX a little bit, then you'll know that calculate overrides any filter context that's been applied by default. So I can override that. That's why measures come in pretty handy to create other visuals, because now I can create a visual object based on a measure that I've generated, which essentially is what this is. You can see that, and the reason for this is because we have inactive relationships. I have a relationship between my date key, boom, boom, and several different things. But you also see that I have ship date key, and my active relationship is order date key. Well, what if I want to see sales by ship date, not necessarily by order date? I can override that context now by using my use relationship. So calculate overrides the filter, and then I've created this measure to essentially say use the relationship between the ship date key and the date rather than the order date. And that'll override that. And now you can see that I got the ship date, sales by shipping date created its own. And then I can see the sales amount in here. So for comparison, I could also create a, just sales by order date in here. If I wanted to create, let's get in here real quick. And I want to say
Well, that's by month. Yeah, so I can see sales by order date. Since the default is the order date, this light blue one are my sales by order, right? And these are my sales by shipping date. So there's discrepancies happening here. The sales by shipping date, these are things that we need to look at to see why our sales by shipping date were different than our order date. It could be because something was ordered at the end of the month and it didn't get shipped till the next month. That's usually what you'll see discrepancies like this, but we want to make sure that we're finding out what the reasons are behind this. That's all about analytics. And then finally, we can, again, override a cross-filter relationship. So not only can we activate inactive relationships, we can override the cross-filter direction that was in there. And in this case, we're applying a bidirectional and overriding the unidirectional relationship between that. So a lot to cover about relationships. It's a really important concept because if you have bad relationships built into your model, your analytics are not going to be accurate, and your users are going to experience some crazy things. Bad decisions get made. A whole lot of bad things can happen. So model relationships are important. Back to the studio.
Great work, detectives. You just solved several mysteries related to model relationships. You learned how to set up and configure relationships between different tables of data, how to choose the right cardinality and cross-filter direction, how to activate or deactivate relationships using DAX functions, yes, DAX, and how to understand relationship evaluation and precedence rules. You also learned how to apply star schema design principles and how to use various DAX functions to work with relationships. Did I do good, DAX? DAX approves. Thanks for joining.